Hi everyone, this is Professor Hess. Today I'm going to be giving you a mini lecture on the electrophilic substitution of benzene. So again, we're going to be talking about the electrophilic substitution of benzene. And specifically, we're going to be looking at the mechanism and this is the molecule we're talking about, which is benzene, as we talked about in class. It's a highly unsaturated molecule, and because of its stability, what we see that it undergoes electrophilic substitution. So the mechanism electrophilic substitution of benzene. Let's get started. All right, to begin with, let's start with the reaction as we always do. So we're going to be thinking about the fact that benzene, and again, when I do my reactions, I can be lazy and write the fact that we're going to be having an electrophilic substitution using these reagents here. And both of these two combinations of reagents give us the nitration of benzene. And as I told you before in class, you can start with the good electrophile. So this is the reaction over here. And now what I'd like to show you is the mechanism. And remember, when we see the mechanism, I will be pushing electrons. Now, I will also put in some more atoms so that we can follow things a little bit more clearly. But let's start out with the mechanism. Step one is going to be the fact, and again, I'm going to put in all my hydrogens because I think it's important for you to see the hydrogens so that you can look when we start putting charges on the atoms. We know what it is. I'm going to change my pen over here and number my carbons. And if you notice again that right now I have a double bond between 2 and 3, 4 and 5, and 6 and 1. And now I'm going to go ahead and have my electrophile. And in this case, the electrophile is going to be the nitrogen. As I said before, we went through this mechanism, and it has a positive charge. Remember before how we said in class that the positive charges are going to be circled so we don't get confused with what they are in the reaction, if it means adding it. So here we have our two reagents starting out, and remember we have to decide who is the nucleophile. And as we talked about in class, the nucleophile is going to be the benzene ring because it has the electrons, and this nitro group is going to be the electrophile because it has the positive charge on there. And when we start this mechanism now, we know then that the bond from the benzene ring, and again, it doesn't matter which one we pick, we just have to be consistent when we start drawing a resin structure. So I'm going to show that the bond between 2 and 3 is going to go after that nitro group, right? And now we'll draw the next step over here, showing what happens. Now, if you notice, again, I'm going to put in all my hydrogens because I think that's important so that you count which ones have 4 bonds and which ones are missing 4 bonds. And then again, I'm going to shift back to numbering my carbons again so that we make sure we keep our double bonds in the right place. And so based on what I've drawn, I still have a double bond between 1 and 6, and I still have a double bond between 5 and 4. But now that double bond between 2 and 3 is now being used to bond with that nitro group. So it doesn't matter where you put the nitro group on the 2 or the 3. I'm going to go ahead and put it on number 2 over here, and then I'm going to be lazy and just draw it as NO2 because it doesn't really matter about the structure of it. Now if you notice over here, this carbon number 2 has 4 bonds to it, right? If we count, there's 4 bonds to it, so that bond is never going to have a positive charge on. But if we notice at the carbon number 3, we notice that there's only 3 bonds. So that carbon then is going to be the one that is going to have the positive charge over there. Now you're going to be required to draw resonance structures, so let's go ahead and draw a resonance arrow here, and we're going to have to show how that positive charge, and again the word we use, I'm going to erase that because I don't want to use, I'm going to go back to using the yellow that I started using before. We have to have resonance structures, and we're going to delocalize, which means we're going to be moving that positive ion around to show how very stable it is, because that charge doesn't have to stay on carbon 3. Let me get my electrophile back onto carbon number 2, and then I'm going to go back again, and I'm going to keep my carbons numbered 1, 2, 3, 4, 5, and 6. And now what I realize is that I'm going to basically make a resonance structure, so I have to decide how I'm going to move that positive charge around. And remember, the positive charges can only go between, in other words, bond number 4 has the double bond between 5 and 4. That's the one closest to the positive charge, and that's the one that's going to move over and take the positive charge by putting the bond between 4 and 3, and then bond 5 is going to be the one that's going to end up with that positive charge. So that means that the bond between, whoops, I numbered my carbons wrong here. Let me erase this over here. So I've got, make sure you keep it right, 3, 4, 5, and 6. And so that means that I'm going to keep the double bond between 1 and 6. Okay. But now this bond over here is going to move between 3 and 4, and I'm going to have the double bond over here. And then that means that my positive charge is now on carbon number 4. Now, if you remember, we talked about this in class. Right now over here, in this structure between 2 and 3, the new group and the positive charge are now ortho to each other. Remember, that means they're next door neighbors. But in this structure over here, if we notice the 2 here, that between 5 and 2, those are para to each other. So always think about the fact that you need to draw 3 resonance structures. So that means that there's one more that I have to draw, and it's always ortho to the new group, para to the new group, and then we're going to do ortho again to that new group, but on the other side of it. So again, I'm drawing in my hydrogens again. And again, I highly recommend you do this to make sure that you don't lose any bonds, making sure that you're not adding positive charges to things that shouldn't have it. My nitro group is back over here. Number my carbons again. This is 1, this is 2, this is 3, 4, 5, and 6. And again, now this positive charge at carbon 4, remember the positive charge was already on 3, so therefore we have to move it over to carbon 1. So that means that this pair of electrons needs to move in this direction over here. And then that also means that the double bond between 3 and 4 doesn't move. Now the double bond is over here, and now what we have is that positive charge on carbon 1. And again, now the new group and the positive charge are now ortho to each other. So those are the 3 resonance structures you have to show when I ask you to do the mechanism. Now this is the step where, again, the nucleophile attacks the electrophile. Now I'm going to go on and finish the reaction, because remember, it's called electrophilic substitution. So now what I have to do is basically get rid of the hydrogen at carbon number 2 so that the ring can go back and be aromatic. So just to recap again, is that when we do the mechanism, you're going to be required to draw these 3 resonance structures showing that the positive charge can be delocalized ortho to the new group, para to the new group, and then ortho again. So I'm going to just go ahead and you can basically finish the mechanism off with any resonance structure, any 3 resonance structure. I'm just going to take the last one, and again I need to go to a new page over here. I'm going to be redrawing this. I'm going to take this structure over here, and that's the one that I'm going to finish up the mechanism with. And let me change my pen back to yellow. So in step 2, we're basically going to take that one that I've just shown over here. But again, you can use any resonance structure to finish up the mechanism, because all of them will give you the same final product. And let me go back and just make sure. I'm going to number my carbons again if I've done it correctly. This was 1, 2, 3, 4, 5, and 6, but I'm going to go back and just make sure that I've done that right. So I have a double bond between 5 and 6 and 3 and 4. Okay. And then my positive charge is on this carbon over here, number 1. All right, so in our last and final step, what we're basically going to do is, as I said, is just eliminate this hydrogen. And the bond is now going to come between these two bonds, between 1 and 2. And then we finish off the mechanism because, again, the final step is always the return of the double bond into the ring so that substitution occurs and that the ring is once again aromatic. But now instead of having a hydrogen there, you've inserted your new group over here. And yes, there's a hydrogen somewhere in solution, but for this reaction specifically, we already have lots of acid in solution, so it's done. So this is a substitution reaction where again we remove the hydrogen and we put our nitro group on. So those are the steps in the electrophilic substitution reaction. And if we go back over here, this mechanism is the same. The only difference that we're going to be doing is that we will be changing the electrophile. But again, this type of mechanism is going to be the same for any type of group that we put on for mono substitution. So this was the mechanism for mono substitution of benzene. Okay, the next video I'm going to do where we have a group on the aromatic ring and we see what happened in the substitution there.